Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Fatima Khalid from Multan Public School and College. I hope that all of you are fine. Now we are going to start chapter number 6. The name of the chapter is The Particle Model of Matter. What is matter? Anything that has mass and occupies space is called matter. Living things and non-living things are the example of matter. Students, here is a question that what makes up matter? So according to Greek philosopher Democritus' hypothesis that all matter is made up of tiny discrete particles which are too small to be seen. He named these particles atoms, which is derived from Greek word atomos, which means indivisible. According to another Greek philosopher Aristotle's hypothesis that matter has a continuous composition, which can always be broken down into smaller and smaller pieces. Students, one question arises here that whose hypothesis was right, Democritus or Aristotle? Let us look at two phenomena, Brownian motion and diffusion. These two phenomena will provide us with evidence as to which hypothesis was correct. Robert Brown was a Scottish botanist. In 1827, he used a microscope to observe some pollen grains in water. He found that the pollen grains were moving about in the water randomly. This random movement was called Brownian motion. What is Brownian motion? Random movement of small particles in a liquid or a gas. For example, pollen grains or smoke particles. Albert Einstein was a scientist. About 80 years after Robert Brown's observation, Albert Einstein explained that the random motion of the pollen grains in water was caused by tiny water particles, which were moving in constant and random motion, bombarding or hitting the pollen grains in different directions. So, Brownian motion can be explained by thinking of matter as being made up of tiny discrete particles which are moving constantly and randomly. What is diffusion? Diffusion is the movement of particles from a region of higher concentration to a region of lower concentration. Diffusion happens in liquid and gases. For example, when perfume is sprayed at one part of the room, it spreads throughout the whole room due to diffusion. Perfume particles travel from higher concentrated area to the entire room, where the concentration is less. So, diffusion can be explained by thinking of matter as being made up of tiny discrete particles which are moving constantly and randomly. Development of the particle model of matter. Students, early scientists could not directly observe the tiny discrete particles that make up matter. They had to make inferences about their existence from other observations. Brownian motion and diffusion provided scientists with the necessary evidence. Today, it is possible to observe the tiny particles that make up matter by using advanced instruments such as the scanning tunneling microscope. This provides clear evidence that Democritus' hypothesis that matter is made up of tiny discrete particles was correct. What is scanning tunneling microscope? Students, scanning tunneling microscope is an advanced microscope that allows us to see the tiny discrete particles in matter. The scanning tunneling microscope has a sharp pointed probe that acts like a sensitive finger. When the probe runs back and forth over a surface, it detects the roughness of the surface very accurately, and hence allows the position of the particles in the matter to be visualized. The probe can apply forces to individual particles and move them to desired locations. Based on evidence from observations and investigations, scientists have accepted the particle model of matter. So, the particle model of matter states that matter is made up of small discrete particles. The small discrete particles in matter are in constant and random motion. Particle models for solids, liquids, and gases. Students, matter can exist in three physical states: solids, liquids, and gases. Solid. Students, in a solid, the particles are packed closely together in a regular pattern. They are held together in fixed positions by strong attractive forces. The particles only vibrate from side to side and spin about their fixed positions, but cannot move past one another. This is why a solid has a definite shape and a definite volume and is unable to flow. A solid cannot be compressed because its particles are already very close to one another and are held by strong forces in fixed positions. Students, in a diagram, you can see the arrangement of solid particles. Liquid. Students, in a liquid, the particles are not arranged in a regular pattern. They are not as closely packed as those in solids. The particles vibrate but do not have fixed positions. They move around one another. Liquid can flow and take the shape of any container in which it fills. The particles of liquid are also held together by strong attractive forces. Liquid has definite volume but not definite shape. The particles of liquid cannot be compressed. Students, in the diagram, you can see the arrangement of liquid particles. Gas. Students, in a gas, the particles are widely spaced. They move freely and randomly in all directions and at high speeds, colliding with one another and the walls of the container, giving rise to gas pressure. The particles spread out as far as they can to fill up any container completely and quickly. Gas has no definite shape and volume. The shape and volume of a gas is the same as that of the container in which it fills. There is little or no force of attraction among the particles of a gas. So, due to this, gas can flow easily. The particles of gas are widely spaced and not held by strong forces. So, gas can be compressed easily. Students, in the diagram, you can see the arrangement of gas particles. What is density? Density is the mass of a substance per unit volume. Students, solids have high density. Liquids have less density than solids, while gases have low density. Changes in physical states. Students, a substance can be a solid, a liquid, or a gas under some conditions like temperature and pressure. For example, gold is often seen in solid state. Just like ice, gold can melt into a liquid, and then liquid gold can changes into vapor state at high temperature. Melting. Melting is a process by which a substance changes from solid phase to the liquid phase. For example, melting of ice. Freezing. Freezing is the process in which a liquid changes into solid. For example, water freezes into ice. Boiling. Boiling is the process in which liquid changes into gas at boiling point. For example, water boils at 100 degrees Celsius. Condensation. Condensation is the process in which gas changes into liquid. For example, water vapors changes into water droplets on a glass. Sublimation. Sublimation is the process in which solid directly changes into gas phase. For example, iodine crystals changes into iodine vapors. Dear students, this was your whole chapter. Thank you and Allah Hafiz.